So in this video, we are going to see about the problems on a digital to analog converter. So this is a digital to analog converter. Here, in the problem, they are given the value of VR. VR is equal to 10 volt, and they have given I here, and R value is 10K. Okay, this is 10K, so this is nothing but 20K. Okay. So they have asked you to find the value of this current. Okay. So this is minus and this is plus. Okay. So we know that due to the virtual ground, if this is 0, this point is also 0. That is, this is also grounded. Okay. That is virtual ground. If this point is grounded, means this point also grounded. So you can see this is also 2R and this is also 2R. So if the current going through this 2R is I, means the current going through this 2R also, it is I. Okay. So if this is I, this is also I. So what is this current? This is nothing but 2I, right? Because the incoming current is equal to outgoing current. So if this is 2I, means this is also 2I, because if I since these two resistors are in parallel, so this value is equivalent value is R. So R plus R is 2R. So this is also 2R, this is also 2R. So if the current going through this resistance is 2I, means this is also 2I. So similarly, this is, if this is 4I, means this is also 4I. Okay. So the current flowing through this one is 4I, means what is the current at this point? At this point is nothing but 5I. Okay. So for the op amp, the incoming current is 0. Okay. So if this is 0, means the outgoing current, this current only, it is flowing here. So this is nothing but 5I. Okay. So I can write V naught is equal to minus 5I R. Okay. So V naught is equal to 5I R. So since the current is flowing in the opposite direction, it is V naught is equal to minus 5I R. Okay. So in this value, at this point, it is 10 volt, right? So the voltage across this one is 10 volt. So I can write, if this is 8I, means this is also 8I, right? So I can write VR is equal to 8I into 2R, right? So from this I can find the value of I. I is nothing but 8I into 2R. Okay. So that is nothing but I is equal to VR divided by 16R. Okay. So I substitute here, minus 5R into VR divided by 16R. Okay. So R get cancelled out. So you will get minus 5. What is the value of VR? VR is nothing but 10. So you will get 50 divided by 16. That is nothing but minus 25 divided by 8. Okay. So let me go for the second problem. 4-bit DAC is connected to a free running 3-bit up counter. So this is your DAC and it is connected to a up counter. Okay. So which one of the following is output is observed at the V0? Okay. So you know the up counter value. So you have 3 outputs. So it ranges from 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. So what is the value of my D3, D2, D1 and D0? D2 is always 0 and D3 value is nothing but Q2 and D1 value is nothing but Q1 and D0 value is Q0. Okay. So if that is the case, first initial value is 0 and the next value is 0, 0, 1, and the next value is 0, 1, 0, right? 0, 1, 0, and another value is 0, 0, 1, 1. So you can see this is 0, 1, 2, and this one is 3, next one is 4, next one is 5, and next one is 6, and next one is 7. Okay, so after that it is moving in the same direction, right? So what is this value? This is 0, this is 1, and this is 2, this is 3, and this one is 8, and this one is 9, and this one is 10 and 11. Okay, so you can see 0, 1, 2, 3, and this is 8, 9, 10, 11. Again it will go to 0, 1, 2, 3, and 8, 9, 10, 11. Okay, so the B is your answer. So next we will go for the another problem. So the output of the 3-stage Johnson counter is also called as twisted ring counter. Okay, which is connected to a digital to analog converter, which is shown in the figure. So initially, so if this is 0, 0, 0, what is a Johnson counter? Johnson counter will 1. So the 1, so this value is inverted. This value is inverted, and that is given to this one. Okay, so this value should be inverted. This value should be inverted, and it is given here, and this should be shifted. Okay, so again this value is inverted, and this value should be shifted. Again this value is inverted, and this is shifted. So again this is this one is inverted, and 1, 1, and 0, 0, 1, and 0, 0, 0. So this is a state. So first one is 0, next one is 4, next one is 6, 7, and 3, 1. Okay, so you can check the okay. So this is 0, and this is 4. Okay, and this is 5. Okay, so it is round. So this is 0, this is 4, and this is 6, 7, and next one is 3, and next one is 1. So your A is the correct answer. So next fourth problem, and 8-bit ADC outputs are all 1 when VA is equal to 5.1. Okay, so find it resolution and digital output when VA is equal to 1.8. So this is nothing but analog to digital converter. So we know the formula, right? Analog is equal to resolution into gain into digital value. Okay. So here the VA is nothing but analog input. That is nothing but 5.1. That is equal to resolution, and the gain value is always what. Here it is not given, so I have considered it as 1. And what is the digital value for all ones? So for all one it is 255. Okay, for 8 ones, 8 1 value is there is nothing but 255. Okay, so what is resolution now? So resolution is equal to 255 divided by 5.1. Okay, so this is for A, and second one digital output when VA is 1.8. So the analog value is equal to resolution is 255 divided by 5.1 into the digital value. So what is the digital value now? Digital value is equal to 5.1 divided by 255 into the analog value. Analog value is your input value, that is 1.28. So if I multiply, I will get answer as 64 LSB. Okay. So 0, 0, 0, 0 is your 15, this is 16, 32 and 1. So this is your answer. Okay. 1, 2, 4, 8, 16, 32, 64. So next problem, calculate the quantization error for 12-bit ADC with full scale input voltage of 4.095. So the quantization error Q is equal to full scale output voltage, input voltage 4.05095 divided by 2 power n minus 1 into 2. Okay. So this is nothing but 4.095 divided by 2 power 12 minus 1 into 2. So you will get answer as 0.5 millivolt. So next problem is based on ADC, successive approximation ADC. So an 8-bit successive approximation ADC is given by a 1 MHz clock. Find its conversion time. So the conversion time TC formula is n. N is number of bits into T clock. Okay. So what is T clock? T clock is equal to 1 divided by frequency. That is nothing but 1 divided by 10 power 6. 1 mega means 10 power 6. That is nothing but 10 power minus 6. So you will get 8 into 10 power minus 6 seconds. Okay. So this is how we have to calculate. But since it has some start of conversion and the end of conversion, so it will consume one clock cycle for the 1 T clock for the start of conversion and 1 T clock for the end of conversion. So it is 10 power 6 plus 10 power 6. Okay. So you will get 10 power 10 into 10 power minus 6 seconds. That is nothing but 10 microseconds.